Hello everyone, in this video I will be demonstrating how to export this timber model created in Rhino into the structural analysis software RSTAB. In RSTAB we will be able to see the deformations, internal forces, and support reactions based on load combinations that we will be generating based on the TimberFever engineering guide. The first thing we need to do is separate the center line layer in Rhino from the surrounding lines that make up the parameter of the members. If you still have the decking and bench in this model, you can delete that because we do not need that for the structural analysis side of things. So things like these lines right here, we can simply zoom in here and select and delete them. We can do the same thing down here. And then we want to make sure that all of those lines are missing. And then what we can do is go down here to center lines and turn off the yellow lines, the silver pine lines, and then all we are left with are our center lines. So normally, or you might come across a situation where an architect supplies you the Rhino model and the center lines are missing. In this case, you will have to add in these center lines manually. But with this example, we do have the center lines created, so we do not need to worry about that. And you will also see later on in this video why the center lines are very important to have when doing a structural analysis. Next, what we need to do is, before we can export this into RSTAB, we need to highlight the whole model. And now we can go up to File, and then we can go to Export Selected. And under Export Selected, this is where we're going to name our file. And we can name it anything we want. For this video, I'll just name it TimberFever export example. And I'm just going to save that to my desktop. And then the most important thing before we save it is we want to change the file type from a .3dm to a .dxf file. And what we can do is scroll down here, find the .dxf file, hit OK, and then we can hit save. This window is going to pop up, and we can just keep everything as default. We can click OK. So now what we want to do is open up RSTAB, and RSTAB should look like this when you open it up. Maybe your toolbars are a little unorganized, so what you can do is right click anywhere in this space and hit reset to default. The next thing we want to do is go up here to File, and then we want to go to Import. And within this Import dialog box, we have multiple file types we can select from. What we want to import is a .dxf file. Then we want to check out the tab here called ASCII format DXF. And everything in here we can leave as default, except we want to make sure that our template length is in meters. So we'll hit OK. And now RSTAB is asking us what file we would like to import. We can go to where we saved our Rhino exported file locally. Mine's on the desktop. I'll go over here and click it, and then I'll click OK or Open. And now you'll see that our dialog box, new model general data, will pop up. And this box pops up whenever a new model is created. So here we can enter the name of our model. We can enter a description if we would like. We can also save this model under a project folder. And then everything else we can leave as default except for our classification of load cases and combinations here. So this is where we can generate load combinations automatically based on a standard. And for this example, since we were generating our load combinations based on the TimberFever engineering guide, we can just uncheck this button here called Create Combinations Automatically. And then we can go here and click OK. One thing I forgot to mention when looking at the general data is we want to make sure our units are set to metric. So what we can do is go back and change those, and we can go into our project navigator on the left-hand side here, go up to our model name, right click on the model name, and then click on units and decimal places. So right now my units are set to metric, but if yours are set to imperial and you need to change them to metric, what you can do is go down here to this button called Load Saved Profile, left click on that, and then you would want to check the box for metric, click OK, and then you would also want to hit this button here called Default, and that will switch your units over to metric. We can then click OK, and the next thing I want to do is just go over the basic user interface for RSTAB. So to start off, over here on the left-hand side, we have our what we call Project Navigator, and this basically is a panel organizing all of the model data into these expandable and collapsible folders here. You can see we have our nodes, materials, cross-sections, etc. Also keep in mind that all nodes should be in meters, and member cross-sections will also need to be in meters. Down here we have our add-on modules as well listed. We can go over these later, but these are for design. Later on we will be using the Timber CSA add-on module to design some members within our structure here. The next thing that you might notice I have missing is my tables at the bottom. You can turn off your tables by using this button up here in the toolbar, as well as the button next to it turns on and off the project navigator. Real quickly, the tables are used for inputting data and also viewing data. So you can see we have our tabs down here for our model data, and we are in table 1 model data, which you can switch between up here with these buttons, between different tables. Table 2 is used for looking at load combinations or entering load combinations. For this tutorial though, we don't need to get into using the table, so for now I'm just going to turn mine off. Up here we have our toolbar, where you'll notice we have a plethora of buttons that we can choose from, or tools. And these tools, after using them, you'll notice that they are organized, and there's a method to the madness, as someone would say, to how these buttons are placed. You can see over here we have buttons for entering members and lines and supports. Here we have some for loading, measurements, views, and then results. And then we also have some more tools for viewing, some more tools for modeling, and etc. So we'll go through these and I'll go over them and explain them. Up here we have our tools for adjusting load cases and combinations, which I will also get into. So to start off, this is our work window where we will be working with our model graphically. The bottom left here, you can see we have our global axes. So here is our work grid. You can see that right now our work grid is in the XZ plane of our model. What we can do is first we can change this work plane up here with these buttons and we can click on this one called work plane in the XY. So I'll click that, and then you'll see that this grid with the grid points and everything is switched to the XY plane. And you'll also see that these grid points are spaced out evenly. The space between these grid points right now is 1 meter. And if you ever need to change anything about this grid, what you can do is you can go up here to settings of work plane, grid / snap, and object snapping guidelines button. And once we open this, you'll see this dialog box here with a bunch of different options where you can change how many grid points are in each direction of your grid and the spacing of each grid point. For now though, we can leave all of this as default and click OK. The next thing I want to go over quickly is just the way we can interact with the program or your model. So basically, if you have a scroll wheel on your mouse, you can scroll in and out, and that allows you to zoom in and out of your model. The other way to move your model around is to click in the scroll wheel, and that will allow you to move your model in translation. And then if we want to rotate the model, we can hold down Control on our keyboard, and then we can click in the scroll wheel and rotate the model as well. Another good thing to know is that highlighting things is different depending on the direction you start and end. So if you start highlighting something from right to left, it'll be a purple box, meaning anything that this purple box touches, it will highlight that object. But if you highlight from left to right, the things that are going to be highlighted have to be engulfed or completely inside of this red box. So those are two ways to highlight within RSTAB. So I'm sure the first thing that you'll notice with these center lines is that they are not all connected right now. So basically what we want to do is we want to go through and make sure, if you zoom in you can see, we want to make sure that all of these red nodes here at the end of these lines are all connected to a line basically. So that's what we want to focus on right now, is getting this model cleaned up. Another thing you'll notice that if we go up here to our toolbar is that we can get an elevation view of the model by clicking on this button right here called View in the Y direction. And you can also see that a lot of these lines are not lined up or completely all in the same plane, as you can see right here with the slope. So what we'll do is we'll go through and clean this up and make sure that all these lines and everything are within the same plane. And also something you could take notice of maybe is that everything is not completely squared off. You can see like this line down here is not completely flat. So I'll go through and show you and give you the basic idea or method on how to clean this up. And then once I give you the tools and everything, I'll go through and speed up this process a little bit on my end, and we can fast forward through it. But for now, the first thing you want to do is take advantage of the fact that this structure is symmetric. So instead of having to go through and fix every single one of these lines and make sure they're all equal and everything, we can simply delete about 3/4 of this model, and then we will use our mirror tool and move and copy tool. So the first thing we can do is go up here and click this button. It should say View in the reverse X direction, but if it doesn't, you can click on the drop down window right next to it, and you can select the button in reverse X direction. And now that'll give us a nice elevation view of the X direction of this model. And then we can go through and we want to drag from left or from right to left. And highlight. And now you can see in red the members that are highlighted, and then we can hit delete. So now this is what you should be left over with, is this section right here of the model. So what we want to do first is make these missing lines up here again. We wanted to draw these lines. So to draw a line, we can go up here to this tool called New Single Member. click on that, and then you'll see that this new member dialog box pops up. And right now we don't really need to focus on any of this information. The member cross-section is just set to some default cross-section with a default material. All we really want is just the line. We're going to define the cross-sections and materials later on in the video. So for now we'll click OK. And then you'll see that we have this, that our cursor has turned into this reticle, and that this box up here has popped up. And what we can do is simply just draw our line graphically. So what we want to do is we can left click on any node to start drawing our line, and then we can left click again on another node to finish drawing that line. So we're just going to connect those nodes, and then we can go up here and rotate our model and connect this left side up here to this right side, right there. So now that we have our beams essentially connected there, we can hit escape, and that will take us out of the tool. We can also go through and click on these floating nodes that we don't need anymore, and we can just simply get rid of those. And now you'll see that we're left with this section here. The next thing we can do is simply just delete these lines right here by dragging from right to left, and then we can hit delete. And we can also do the same thing. You want to make sure that you leave at least one line left. You don't want to delete all the lines. So if you did delete all the lines, what you can do is hit Control-Z or this back button up here, and that will reverse your previous action. Now what we want to do is go down here and do basically the same thing. We'll delete all of these lines except for this last line here. And now what we also want to do is, you can see that the nodes from those lines were left over on this one single line. So we can go through and highlight those and delete them, highlight and delete them. You can also delete this node that was left here. So basically what we're doing is just cleaning up these simple lines here. So we want to go and delete these nodes as well, dragging from left to right, allowing us to just simply select the nodes and not the line. And I can hit delete on the keyboard, and that will delete those nodes. So now you'll see that we're just left with this simple frame here. And what we want to do is just make sure that we get everything squared off and we get everything aligned correctly. So what we can do first is we can simply just take this line, left click and drag it, and we can just drag it to start at this corner node here. Then we can delete this other node right here. And then what we can do is just draw a new line by going up here to the toolbar and clicking on new line. We can hit OK. And now you'll see that this reticle has popped up again. I can rotate the model. And then I can just left click on this node and connect these members here. Now you'll see that that's pretty flat. So if we rotate the model, or we can also just do a view in the Y direction, you'll notice that if you zoom in up here very closely, that these two nodes are not lined up with each other. And we can tell that by zooming in. So what we can do is simply highlight these two nodes. We can right click on either one of them, go to node, and then go to edit. And then you'll see that these two nodes that we're looking at do not share the same X, Y, and Z coordinates because that these boxes are blank. So since these boxes are blank for our X, Y, and Z coordinates for both of these nodes, that means that they do not share the same location. And what we want to make sure is that they share the same Z location and the same X location, so we can make sure they are lined up correctly along the y-axis. So what we can do is simply exit out of this box. We can rotate our model and we can choose this node right here as our reference node. We can double click or double left click on it to open up the edit node dialog box, and then we can see what its Z coordinate and X coordinate are. And what we can do is type these two coordinates into both of the nodes so they share these two coordinates. So we can just remember 1.109 meters for X and 2.199 meters for Z. We can click OK. Then what we can do is drag from left to right to highlight two of these nodes. We can double click on them, and then we can type in those coordinates. So 1.109 for the X and 2.199 for the Z. So now if we go and look at our view in the Y direction, we can see that our nodes are completely lined up along the y-axis in the Z and X direction. The next thing we can do is make sure that our two nodes here are lined up. So again, we can look in the Y direction or the elevation view, zoom in and highlight these two nodes, double click on them, and we can see that they also share the same X and Z coordinate, which is great, so we don't have to do anything with those. We can also take notice that this line over here is not connected to the corner here, so we can just simply left click and drag that line there. Again, we want to look at our Y direction. You can see that this whole frame right here is not lined up or flat. So what we can do is simply make sure that these two nodes have the same X and Z coordinate, which by looking at them I can tell they don't. So I'm going to simply choose this node down here. I can double click on it, see its X and Z coordinate. I'll remember these two, so 2.88 meters for the X coordinate and 0.196 for the Z. So I'll exit out, highlight both of them, and then type those in. 2.88, 0.196. I'll click OK. Take a look at my view again, and now this whole frame is lined up. The last thing we need to do is, or second to last thing that we need to do, is connect this line to the frame. So we want to just simply left click and drag. We can just drag up to that line and then drag up to this line. You do also want to make sure before starting this model that the option Auto Connect Members is turned off. So we wanted to make sure that option is turned off before we're doing this. The next thing we can do is just delete this extra node here, and then we can connect this line to the surrounding frame. So we go down here, connect this line, and then again we can take a look at our elevation view here, and we can see that all of our nodes and lines are all aligned. If we want to make sure that this line, that this whole roof here is completely flat, it looks like maybe it's at a little bit of an angle. So what we can do is simply just draw a line that is parallel with this line straight up. So to do that, we need to set our origin to this frame here, and to do that we can go up to this button called Set Origin of Grid/Workplane. So we'll click on that, and then we'll click on this node down here and set our origin to this node. And then what we want to do next is set our workplane to the X and Z workplane. So we can go up here to this button called Workplane YZ or XZ. And now you can see our workplane or origin is set to the bottom left here, and our workplane is in the XZ plane. So opening this workplane, you can see that also our frame here is not perfectly 90 degrees. So to fix that, we can easily just go up here, highlight these two nodes, double click on them, and we can set our Y coordinate to what this node is right here. So we'll go down here and double click on that node. You can see that our X coordinate is set to 2.88, and then we can go up here, highlight those two nodes, and we can change our X coordinate to 2.88. So now you'll see that our frame here is completely straight. And now what we want to do is draw a line straight up. So we'll go up to our Draw Line tool, our box will pop up here, we'll click OK. And now we can draw our line straight up here to the next grid point. Doesn't really matter how long it is, this is just for reference for our angle here. So what we can do is go up here to this tool called New Angular Dimension. I'll click on that, and now we can measure this angle right here. And we want to make sure this angle is, these two angles are the same. So I'll measure this angle as well, and you can see that they are different. So what we can do to fix this is we can lower this node down so this angle is the same. So what we want to do is simply just do a guess and check, and we want to change this Z coordinate to maybe 1.485. I lowered it, and now you can see that this angle is at 104.61 degrees. So I want to just continue lowering that until it's at the same angle. So that's basically as close as we're going to get it, 1.462 meters in the Z coordinate. So now what we can do is simply just delete this line that we created. We can delete this angle, and now our frame and everything should be lined up. We also want to make sure it's completely square here as well. So what we can do is go up to our workplane here, the XZ workplane. We can switch that, and we can look at our reverse X direction again, and you can see that this is not a square, so we can hold Control, and then we can rotate this, and you can see that these nodes here are not completely lined up in this direction either. So what we want to do is change the location of these two nodes to match the location of these corner nodes here. So I'll double click on this corner node and see and look at its Y location. So it's negative 1.797. So I'll go up here and change this one to negative 1.797. And then I can look at the Y direction or Y coordinate of this node here, which is at negative 2.385. So I'll change this one to negative 2.385. That'll square those off. We can get another look again and just make sure that these are all lined up. Which it looks like they are. So now we can just reconnect this line again by dragging it onto that line, and then we can zoom in this one and make sure this node is also connected here. And then we want to make sure that this node is connected to this line down here. And we just want to go through and make sure that all of our nodes are connected to our lines. So I know that seemed probably like a lot of work just to get these lines connected, but it definitely makes the rest of this modeling a lot easier. Because now what we can do is simply just mirror this whole thing, copy it, make copies of these lines here, mirror this frame here, and then copy, and you'll see that we'll have the rest of our structure created. We can always go back to our Rhino model and just make sure we have all of the lines needed. So it does look like we're missing one line at the bottom. So what we can do is go back to RSTAB and just simply redraw that one line that we're missing by going up to our Draw Member tool. We'll click OK. Then we can simply just left click on that node, and then we can go and you'll see that the perpendicular symbol has popped up telling us that this line is perpendicular to this line, and then we can right click anywhere in the space to exit out of that tool. Now what I'm going to do is select this line here, and then I'm going to go up here and use our move and /or copy tool. I'm going to click on that. And this tool basically does what it says it does. You can make copies of whatever you've selected. So with this line, if we go back to Rhino, it looks like we have 2, 4, 6, 8 lines, and we can simply just draw a line between these two lines here, and then we can click on that line. We can go into details, and then we can see the length of that line, which is 0.22 meters. So we can close out of that, go back into RSTAB, and what we want to do is divide this line so we can place a node 0.22 meters away from this node, giving us our displacement vector. So we can simply just go up to this tool first called Connect Members. We can highlight this frame, and what that did was it divided all of our members here and connected these nodes to each one of them. So now we can click on this line right here, right click, and then we can go to Divide Member, and we can use the distance, Divide Member by Distance tool. And you'll see with this tool open that we can see our member orientations. And so we want to create a node or divide this member with a node from the end. So in this box here, we don't have to do anything except for go to member end here and type in 0.22 meters, hit OK, and it looks like I placed it at I wanted to place that at the start, so I can go back, right click on the line, go to divide member, distance, and we want to type in that 0.22 meters at the member start. So now that we have that node here, we can simply just, again, click on this line, go up to move and/or copy. We want to create 7 copies, and then we want to, instead of typing in our displacement vector manually, we can use this button here called select 2 points and return displacement vector. This allows us to select it graphically. So I'll click on this button, and then I'll click on this node here, and then this node here, and then we can click OK. And now you'll see that our lines were recreated here, and they are all basically connected or close enough to this line. We can connect those in just a second. This line up here we want to drag and connect at the top here. And then what we can do is use our Connect to Members tool, highlight these members, and then zoom in to make sure that they're connected. So if we zoom in all the way, you can see that they are not connected. So we can make sure those are connected. Okay, so these lines up above here are all now connected and set. And now what we want to do is do the exact same thing for this line down here. So we can go back to Rhino, and we can go down here and we can figure out this distance here by drawing a line between them. And then we can click on that line, go over here on the right hand side and hit details, and we can see that that's 0.18 meters distance there. So we'll go back to RSTAB, and then we want to divide this member here. So we'll right click and we'll go up to divide member by distance, and you'll see that this is the member end here. So this is where we want to place our node 0.18 meters away from this node here. So we'll go to member end, type in 0.18, and now we can click on this line, hit move/copy. We want to make, let's see, go back to Rhino. We can see that there's 1, 2, 3, 4, 5, 6, 7 lines. So what we want to do is make 6 copies of this line. Click on this button here to set our displacement vector, and then we can click OK. And now you'll see that our lines were created, and they all should be connected, but we might have to connect them manually here. When connecting these, we want to make sure that they are snapping to the line. And now before we mirror and copy this, we want to click on our connect members button up here and highlight the whole thing and make sure they're all connected. Now basically that's the hard part. Pretty much the hardest part of this whole modeling process is getting these connected and straightening everything up. Now we can move on to the easier parts, where we can simply just take this whole thing. We want to just highlight from right to left, making sure that we get all of these lines in here. We don't want this center line here. This is going to be our mirror line. So I'm going to go up here to mirror, and then you'll see this mirror dialog box pop up. You can see the graphic here on the right telling you what your mirror is going to look like. Not exactly your model, but it's going to give you an idea of what will happen. So we'll hit create copy, and then all we want to do is change our mirroring plane to the XZ plane. And then what we want to do is pick a mirroring plane here. So we'll select the first point of our mirroring plane, and now that that's selected, we can simply hit OK. And now you can see that we have basically half of the structure that we had before. Again, we want to go in here and just make sure that our nodes have been set to our, or have been connected to our lines by zooming in. And now everything is connected. The next thing we want to also make sure is that all of our members have the same orientation, like our posts here and our beams up here. So it looks like our beams right here, this whole beam here has a different orientation than this one, and I can tell that because of the red arrow right here. Is I will change this whole line's orientation to match these two right here, and to do that I can simply just highlight this whole line here, and then I can right click on it and go to members, and then I can go to reverse member orientation. Oops. Yeah. So now our member here is in the same orientation as these two members here, and now I can do the same thing with these members here. So these two are in the same orientation, but this one's not. So I can simply also just hold Control and select each one of these, and then I can right click and go to member, and then go to, so I can simply hold Control and then hold Control and select all of these members. Then I can right click and I can hit go to reverse member orientation. So now these members have all the same orientation. Also can see down here that maybe some of my, again, lines are not connected, so we want to make sure those are all connected. The next thing we want to do is make sure that all of our beams here and posts here all have the same, or we want to make sure that all of the local axes are oriented the right way. So it looks like they're all oriented different ways. So what we can do to fix this, the simplest way is we can just go through and delete our lines here. And now that our lines are deleted, we can simply just select this line here, and then we can hold Control and drag, and that will drag and copy our line. And And then we can do that one more time. And now we have that same line, and all the axes are in the same orientation. We want to zoom in and make sure that all of our posts are connected to our lines here. So what we can do is just drag and drop those. And make sure those are all connected. We'll go up here and it seems like this one is not. So now that we have the local axes of our beams and posts here all aligned, we can just right click and turn those local axes off. And then what we can do is double check each of our connections here again. Everything looks good. So now the next step is to move and copy this whole thing. So I'm going to highlight it, go up to move and copy. I'm just going to make one copy, and I'm going to make the displacement vector pretty much the whole width of the structure. So it's going to go from this side to this side, and then I'm going to click OK. And now we have our second half here. And again, what we need to do is make sure that all of our lines here, our connections, are all connected. So it looks like all of our connections are good, and our whole structure is connected here now. We can go up here to our X direction, or I mean our elevation direction, our Y direction, and we can see that all of our lines are nice and lined up and nothing's disconnected, and our whole entire roof is flat up here. And then we can also look at our reverse in the X direction, and we can see we have a nice flat squared off roof with everything lined up. So that's great. We can go up here and set our isometric view, and now we get a nice view of our structure here. And the next thing we can do is to define our cross sections and materials for these 1D members. For the structure, we will be picking from the mixed group of material called SPF, or spruce, pine, and fir, and the grade we'll be using is number 1 and 2. Also keep in mind that wood grades are defined standards based on the size of the cross section, so you should expect your model to use a few different types of material grades. Since the wood could vary between 2x4 and 10x10 during the competition, make sure you take a look at the TimberFever guide for a table that will guide you with this. One thing that we might want to change is that the line here needs to be connected a little farther over. So we can take this line and reconnect it to this line. We can do the same thing over on this side. Make sure those are spaced evenly. And then what we can do is take and go up here to our tool, connect members, highlight this, right click, and then all of our lines here should be connected. So now to define our cross sections and materials, we want to define two different cross sections, one cross section for our beams and posts here, and then another cross section for our small members here, which are going to be truss members. And then after that, I'll explain the difference between a beam type member and a truss type member. So first, I'm going to simply just highlight all of these larger members that we have here. And I also want to highlight all of our whole beam member here, which you can see is in separate lines. So what we can do is rotate this model, and then we can just simply drag from left to right and select all these individual lines here. Don't worry if you select lines that you don't want to select, you can always deselect them after doing this. Same goes for lines that, oops. Same goes for lines that you wanted to select but didn't get to select. So we can just hold Control, making sure we keep holding Control to select multiple lines at once. And then we want to do the same thing for these lines down here. And you'll see that we have these smaller lines. We can hold Control and deselect those because we don't want to and then we can do the same thing by selecting this whole beam here, this one as well. We can hold Control and select these smaller lines that we deselected. We also want to make sure we select this line here and this one as well. So we pretty much want to select all of the lines except for these diagonal lines here that are going to be our truss members with smaller cross sections. And now what I can do is double click on any of these lines, and you can see our edit member dialog box has popped up. And what we can do now is define our cross sections and materials within this dialog box for, you can see the member numbers that we selected. Right now we are going to be using the beam type, which means that these members can take bending, tension, and compression forces, and that they have no hinges on the end of them. They are fully fixed members. So I can go here to this button right here under cross section called Import from Cross Section Library. And here I want to choose a rectangular timber section. So for this cross section, this is going to be our post and beams. So I want it to be 127 millimeters by 127 millimeters. And then we can go into our material library and set the material. And then up here we want to filter to the material timber. And then we want to filter to the category all. And then we can just filter to the standard group. CSA, Canadian Standard, and the latest standard. And then we want to filter to table 6.4. And here you'll see we have our list of materials from table 6.4, and we want to choose SPF number 1 and number 2. So we'll click on that, click OK, and then we'll click OK again. And you can see that now we have our cross section and we have our material defined for that cross section. So we can click OK. And now we have all of our posts defined, our cross sections and materials. One thing I would like to mention before we move on is that timber, every connection should have a moment release. There can be no moments taken by the end and start of the members here at the connections. So we will be defining some member hinges, but before we define the member hinges, we can define these cross sections and materials for these smaller members here. So Again, to do this, we can easily just hold Control and then highlight, making sure that we don't select, we can rotate our model and making sure we don't select any of the beams. So we'll hold Control, keep holding Control, and from right to left we'll highlight these truss members. So I'll click OK. So now what we want to do is double click on these lines, and with these lines we want to make them a truss member, and changing the member type to truss means that these lines now have fully released or pinned connections, so the moments are fully released to the connections, which is how every connection should be with a timber structure. So now we can go down here and we can go to Import from Cross-Section Library. And within this library, we just want to go to Parametric Timber Sections, Rectangle. And then these are going to have a cross-section of 50 millimeters by 50 millimeters. And then we can click OK. Now that we have all of our cross-sections defined and our materials defined, we can move on to creating our supports for this structure. But before I get into that, I would like to show you this button up here where you can change your rendering options. So if you hit this drop down, you can change from a wireframe view. And you'll see this is basically the reason why we needed those center lines from Rhino, is because members within RSTAB are basically just 1D member elements, and the cross-section properties and material properties are embedded within these 1D elements. And these renders that you see are simply just that. They're just renders for aesthetics, basically. And so that is the main reason why we need those center lines from Rhino, is because we cannot create these members without them. So I'm going to change this back to a wireframe view, and I'm also going to delete these extra members that are sticking out the bottom here because we do not need these. I should have deleted those in the beginning, but we can delete them now. And now we can move on to defining our supports. So to define the supports, all we can do is simply just highlight the nodes we want to apply the supports to. So for these nodes down here, we're going to apply nodal supports. So we'll highlight those, and then we can simply go up to the button up here in our toolbar called New Nodal Support. And the nodal support we want to define is a hinged nodal support. So you'll see in this drop down that we have rigid and then a rolling support that slides in the X direction, and same with Y. For now, we're just going to keep this as a hinge support. You can also, if you ever need to create a new nodal support type and define the degrees of freedom you would like to fix, basically. So we'll stay with hinged and we'll click OK. And now you'll see that these nodal supports that are hinged are now assigned to our nodes here. And now the next nodes that we want to support are these nodes right here. And we want these to be a rigid support. So we'll hit the drop down rigid, we'll click OK, and now you'll see that those rigid supports have been applied to our post here. And these will act as the decking that are going to connect this whole member and post here, or whole beam and post here. So now that our supports are defined, we need to define the member hinges of our members here. So what we can do is double click on our members here. One thing that I did forget to do was add in my beam here, so that's easy. I can simply just go up here to new single member, And then I can go to our 100 by 100 millimeter cross section here, or 4 by 4, and click OK. And now I can simply just draw back in that beam by clicking on the nodes. And now we have that beam in here. So now back to adding the member hinges. What we can simply do is just add our member hinges to our members right here. So we already have member hinges applied to, or we already have the bottom of these members released in rotation. So what we want to do is double click on all three of these and add a hinge to the end of the members. And again, you can see that the end of the members, you can see which orientation these members are in based on this red arrow. So my third member here is facing the opposite direction of these two, so I want to reverse that by right clicking on it and hitting reverse member orientation. So that I'm going to highlight these three, double click on them, and I want to add a member hinge to the member end. So I'm going to go down here and go to this drop down, and you can see that we don't have any member hinges defined right now. So what we need to do is create a new member hinge, or define one, by clicking on this button called new hinge for member end. This dialog box will pop up for a new member hinge, and right now I just have, you can see I have my 6 degrees of freedom here. I don't want to release anything in translation along the X, Y, or Z local member axes. I want to just simply release rotation about the Y axes and about the Z axes. So I'll hit OK, and then I'll hit OK again. And you can see that my member is still not in the same right orientation of these two, so I can right click on it again and reverse the member orientation. But now you can see that my hinges are on the wrong side of my members here, so we can just highlight these, double click on them to edit them, and just simply change the hinge from the member end to the member start and hit OK. Now you can see that our hinges here are defined with these dots at the end of our members here. And now we want to add hinges to our beams right here. So we can hold Control and select both of these and double click to edit them. And we want to add hinges to both sides of them. So we'll click OK. And something you always want to keep in mind when adding hinges to members is that you always want to have at least one member at a joint fixed, and that is a rule that you don't want to break, or you'll have a instability within the model. Now we can go through and add member hinges to the ends or starts of our posts here. So we'll start off with the post. We'll add member hinges to the ends of these, or the top of them. So we'll double click and edit them. And we can add hinges to the end and hit OK. And then we also want to add hinges to the ends of our beams here. So this one is going to be at a hinge at the start. So I'm going to double click that one. And then add a hinge to the start. I'm going to double click this one and add a hinge to the end of it. I can also just simply double click or select all of these beams right here So I can add hinges to the end of them since they're all in the same orientation. And now I want to add hinges to the start of these members right here. And there we go. Now our posts here and our beams here each have hinges at the end of them. And at our joints here we have still at least one member that's fixed at each joint. You can see 4 members frame into this one joint, and there's only 3 hinges, so that's good. Now we lastly want to add hinges to the tops of our members, or to the ends of our beams up here at the top. We also can go through here and make sure that our orientations are all in the same direction, so we can just simply right click and hit reverse orientation. We can all make sure it's going from left to right. So now I want to add member hinges to the start of this member, the start of this member, the start of this one, and the start of this one. I'll hold Control to select all of them and then double click them, and I can add a hinge there. And then I would want to add a hinge to the end of this member, the end of this one, and also this one. And there we go. We have our hinges at the ends of these beams up here. So those moments are released. And now all of our connections have fully released moments, which is what all timber structures should have. So that basically completes the model data. Now what we have left to do is add in our loads, load cases, and load combinations, and then define the loading for each load case. And then we can run our calculations. So to add in our load cases, we can go up here to this button called New Load Case. I'll click on New Load Case. So now you'll see that the Edit Load Cases and Combinations dialog box will come up, and you can see that we have our first dead load case here. I simply typed in dead load for the load description, and then you can see we have a list of action categories per the MBC 2015 standard. For dead load, I'll choose dead, and then for self weight, you can see that that's activated by default, and we have a -1 factor in the Z direction, giving us our self weight of the structure or gravity loads. And now we can create a couple new load cases using this button down here for creating new load cases. This second load case, we'll name it snow, and then we'll set the action category to snow. And we'll name this one wind in positive X, so this will be the wind in our global positive X direction. And we want to change that action category to wind. And then this fourth load case, we're going to name wind in positive Y, so that'll be wind in our positive Y direction. And we're going to change that action category to wind. So these will be the load cases that we'll work with. And now what we want to do is superimpose these load cases into what is called a load combination. So what a load combination does is it adds these cases together, and this first load combination, we'll just name it CO1, and this first one will simply just be the dead load, and you can see that we can add a factor or a multiplication factor to our dead load here, and we can do that down here by changing this number, and we'll make it 1.4. So 1.4 will be multiplied by the dead load, and we can set that by hitting the checkbox. And now you can see 1.4 is set up here. So keep in mind, you don't want to have the software automatically generate the load combinations for you. Make sure you see the TimberFever engineering guide for the competition, and this will give you your load combinations and load factors as well. But for just the example, we can go down here again to create a new load combination, and we'll just name this one CO2. And this one I can combine our dead load and our snow load. So I'll move dead load over using this arrow, and then I'll move the snow load over. And for dead load, I will make I'll keep the factor as 1.25, and the snow load I'll leave as 1.5. So I'll create another load combination. I'll just name this one CO3, and this one will be the dead load times 1.25 plus 1.5 snow load, and then plus 1.4 times the wind in the positive y direction. So we'll have to change this to 1.4, hit the check mark, and then we'll just create one more or two more load combinations. And this next one I can simply just copy CO3, and we can just add in wind in the negative x direction and change this factor to 1.4. Hit enter, change this factor to 1.4, and then hit the check mark. And then we'll just create one more load combination. This will be CO5, and it'll include dead, snow load. And now we can move on to our result combinations. So basically what a result combination is it's an envelope solution of all of the load combinations. And what this means is our result combination will superimpose all of our load combinations and give us the minimum and maximum or best and worst case scenario for things like deformations and our internal forces and support reactions. So you can see CO1 through CO4 is added. We also need to change our criteria in here to permanent for each of our load combinations here. And our group to 1. And now that our result combination has been created, we can click OK. So now that we created our load cases, load combinations, and result combinations, we can create our loading, or add in our loading for each load case. So we can go up here to our drop down and make sure that we have dead load selected. And now we can go into adding our loading, and we can do this multiple ways. We can either add nodal loads or member loads, but for this example I'll be using the generated loads option, and I'll be using the from area loads via plane. And within this dialog box here, we want to make sure that our area load direction is set to global related to true area and the z direction, so that's downwards. And then we want to make sure the area of our load application is the full closed plane. Our load distribution type will be combined. The area load distribution will be uniform. And then we'll set our magnitude to negative 0.38 kilonewtons per square meter. And then we also have to choose the corner nodes of our plane. So we can easily do that by selecting them graphically by clicking this button here. And now all I need to do is select my corner nodes, and I'll select the top left one and then go in a counterclockwise direction. Click OK, and then I click OK again, and then I can click OK again. And now you can see that my loading has been added. My 0.38 kilonewtons per square meter have been added to the top of my structure here. And if I want to view them separately, I can simply right click on this loading and hit display separately, and then we can get a look at how our member loads look based on that loading. Now we want to do the same thing for our other load cases, so I can hit this drop down or use these arrows to go to my snow load. I'm going to go up to Tools, Generate Loads, from Area Loads via Plane. We can keep everything the same. All we need to do is change our magnitude, and I'm just going to make this negative 0.48 kilonewtons per square meter. Hit OK. And now we would like to apply our loading for our wind in the positive, or in the negative X direction. I actually made a mistake with this load case. This needs to be in the positive X direction, so I can simply just go up here to edit load cases and combinations, and I can change this to negative, or I can change this to positive. And then I can click OK. And so now I can add the loading in to our wind in the positive X direction. And again, I'm going to use the generate loads from area loads via plane. And I can keep all this as default. The only thing I need to change is the area load plane, except for I'm going to be applying this to the bottom of our roof here. So I need to clear this and then pick just this plane here with these corner nodes. I can click OK. And then the magnitude of this is simply just going to be 0.24. I'll click OK. And again. You can see that was added there. And then we're going to add a wind pressure against our wall here. So again, I can do the same thing. Tools, generate loads. And this time I just want to change the corner nodes to this wall. I'll click OK. And then I'll click OK again. And one thing I forgot to change was the direction. So I'm going to double click on that load, and it needs to be in the global related true area, so I'll click OK. Or the X global related true area. So now we have both of our loading onto, or our wind pressure and the positive X direction onto our wall and onto our roof. And now the last loading we need to add is for our wind in the positive Y. And that will simply just be member loads onto our side walls here. So what I can do is go up here to new member load. And this is our new member load dialog box. And here we can choose our load type as a force, our load distribution as uniform, and then our load direction is going to be in the global Y, applied to the true member length. And our loading here is going to be, our magnitude is going to be 0.073 kilonewtons per meter. So I'll click OK. And then I can just go down here and select our members. And I can select these members as well. And then that will be our pressure side, and then this side will be our suction magnitude or loading. What you can also do is simply just highlight the members you'd like to apply this to. You can see I applied it to these smaller ones by accident, so I can hold Control and delete those as well. Okay, so lastly, we just want to change this suction side. We want to decrease the magnitude of them. So I'm just going to highlight and double click on our loading here. And then I can simply change the magnitude to 0.044 kilonewtons per meter. I can click OK. And now all of our loading is completed for our structure. So we can now move on to run our results. So all we have to do is go up here to this button called Calculate All, and we can click on that. And now you'll see that we have our global deformations right now. So our results have ran, and right now we are looking at the global deformations for our wind and positive Y load case. We can go up here to this drop down and look through different load cases like our snow load, dead load, but most importantly we can take a look at our result combination. You can see we get a minimum and maximum result for our result combination here, giving us the worst case scenario and the best case scenario. And then also you can see on the left hand side here we have our results tab and our project navigator, and that tab only appears when we have results that have ran. And right now you can see we're viewing our global deformations and we're viewing the resultant of the global deformations. We can also take a look at the different components of that, as well as our member internal forces. So right now I'm viewing the moments about the y-axis. We can also take a look at our axial forces as well, along with our shear. And you'll notice that with these diagrams on the members that the blue is positive, which is pointing to tension, and then red is negative, giving us our compression, and that's for axial forces, and for moments those are negative and positive bending moments. So we can also take a look at our support reactions. You can see we have our support reactions for the X and Y and Z, and the X and Y and Z axes. And we can also take a look at our moments about our supports, our moment reactions as well. If we turn those on, those double arrows represent the moments and the single arrows represent the reaction forces. We can also, if we want to, we can just view the maximum values by going down here to the result combinations and expanding that, and we can just click on max values, and we can also take a look at just the minimum values as well. So now that we have all of our results ran, we can move on to designing members in the add-on module, Timber CSA. But before we do that, we need to turn off our results, and we can do that just by going up here to this button called Show Results. And what we're going to do is simply, just for this example, we're going to design these posts right here. And to do that, we need to create a set of members because these posts are all separate members right now. And the easiest way to do that is to simply just go up here to this button called New Sets of Members, and what this does is combines all of these smaller members into one large set of members, which can be designed as one single member. So we'll go up here to New Sets of Members, and it's asking me what members are included in this set. So I'm going to hold Control. Actually, you don't have to hold Control, you can just select them. We're just going to select this one post right here, which is going to be our first set of members. So we'll click OK, and now this dialog box is going to pop up, and we can name our continuous member just post 1, You'll see the member numbers are down here. It's going to be a continuous member, and we click OK. And now you'll see that these dotted lines appeared, telling us we have a set of members right here. And now we can do the same thing for the other 4 right here. Okay, so now that we have our set of members defined, now we can open up the Timber CSA module, which will be under the Data tab in your Project Navigator. You have a list of add-on modules here. You can also find these add-on modules up here at the top in the toolbar, so we can go up here to add-on modules, and then we can go down here to Design Timber, and then we can go to Timber CSA. So basically this add-on module will pop up. It's basically just a dialog box, and you can see we're still pretty much inside of RFM right now. And what this module does is take all of our information, including our materials and cross sections and loading and everything, and internal forces from RFM, and applies the code checks from the CSA, so we can get some design ratios, and we can also optimize our cross sections. So, not to get into too much detail, I'm going to just start off in the general data, input data on the left hand side here. And what we need to do is tell the module which set of members we would like to design. Right now it thinks we're designing all members, so what we want to do is uncheck this all members checkbox right here, and then we want to clear this members text box right here, so we're going to delete that. And then what we want to do is select the set of members we're going to design. So we're going to hit this button, and then we're going to go through here, select our set of members by clicking on the dotted lines here. We'll click OK. And now we're designing the correct set of members. We also want to make sure we're designing according to the latest CSA standard. So we'll click on that. And then down here it's asking us which load cases we want the module to use and to design according to. So you'll see this box on the right hand side here says selected for design. So what we want to do is simply just move our load combinations 1 through 4 over. And you'll see this is under the ultimate limit state tab, so we're just going to stay under this tab. We're not going to do any serviceability limit state design or fire resistant design right now. And now that we have this table filled out, we can just go down here and move down this list of information that we need to fill out. So the next table you'll see is our materials. These extra materials right here don't matter. They're in red because they're concrete and steel, so they can't be designed within this timber module. But you'll see this material right here is the material we're using. So that is imported along with all of the material properties. The next table is our cross sections, which you'll see have been imported in from RFM. Next we have our load duration. So this is normally set based on the standard, but you can see you can change your load duration right here. So dead should be long term, snow and ice and rain should be standard term, and then wind short should be set to short term. We also have our service conditions and treatment of our set of members, so we'll leave this as default. Right now it's set to dry, and the treatment is none or preservative. So one thing I would like to show you before we go into the effective lengths section of the module is if you want to turn on the local axes of your lines or members, you can right click on them and go down to this option called Local Axes Systems On and Off. Click on that, and then you'll be able to see the local axes of your members. And another great way to view where the effective lengths need to be measured is if you turn on your rendering here, then you can see your individual members here a little bit clearer. And next we have our effective lengths. So in the effective lengths, we need to set our effective lengths for our strong axes and weak axes. So buckling about the y-axis is always the strong axis, and buckling about the z-axis is always the weak axis. And we need to adjust the weak axis effective length. So we can leave the weak axis the same, but we need to change the length of the strong axis. So what I can do is click on this value here, click on these three dots, and then what I want to do is select the longest length here. And now that our longest length has been selected, I can just simply go down the list and click on F8, and that will fill in the rest of my values here. This was for, and you can see the set of members numbers listed on the left-hand side here. And then for lateral torsional buckling, we want to do the same thing. So we want to set all of these manually. So I can go down and hit F8, and it'll fill in my column, the rest of my columns, or rows, I mean. And then I want to select the same length here, and then continue and press F8 for the rest of them. And now our effective lengths are set correctly. Next, we have our additional design parameters for our material category and our load sharing. We'll keep all of this as default as well. And then for cross-sectional area reduction, we will leave this alone as well. So now that all of our information has been filled out, we can hit calculate. And you'll see after hitting calculate that all of our results are filtered by design by load case. So it's telling us the governing value for each load case right now. What I can do is, if I want to see the maximum design ratio, which is shown right here as 10.10, which is good, we can actually decrease the size of our members if we would like to get a higher design ratio. I can also view the max design ratio by clicking this drop down and hitting max, and then I can hit apply the selected filter to the results table. And now it's giving me the load combination that is giving me my maximum design ratio. So something else we can also do is review we can view these results graphically. So we can hit graphics down here, and we can turn off our local axes, and we can get a nice view of the design ratios for our stability design and of our design ratios for our ultimate limit state design here. So everything is looking pretty good. These ratios are pretty low, so if anything we would want to decrease the size of our cross sections here. And there it is. We have our members design. You can also do this for the beams up here as well if you'd like, and you can apply this to the rest of the members. So I hope this tutorial was helpful, and good luck with your competition.